Hello, everyone. Can you hear us? Can you see us? Okay.
At least one can hear.
Yes. So we are live. Hello, everyone. Welcome to our fourth webinar in our series on using filming amines. I am Irina. I am the marketing manager at Fineamin, Switzerland. I am very pleased to co-host today's session together with my colleague Simon from CWB in Berlin. CWB is the company representing Fineamin in Germany. Um, Before we dive into the subject that we have prepared for today, the boil out procedure with filming amines, let me briefly introduce Fineamin for those who are joining us for the first time. Simon, can you share the screen? The second slide.
There you go.
Okay. Fineamin is a Swiss company. We are based in Geneva. We are manufacturing water treatment chemicals based on filming amines. Our products are used as corrosion and scale inhibitors in boilers, in cooling towers, closed systems all over the world. We manufacture exclusively in Switzerland using premium materials. We have a modern facility certified for both quality and environment. We have multiple local offices. The oldest ones are in Germany, in Turkey, and in Brazil. And we have some recent ones in Singapore and Mexico. So we bring our advanced water treatment solutions all over the world through a network of distributors. We are currently present in more than 50 countries. Okay, now I will let my colleague Simon to present himself a bit and to present today's subject on boiling out. Thank you.
Thank you so much. And a warm welcome from my side too. Happy that you're joining today. We'd like to share our insights in alkaline boiler procedures with filming amines. Thanks to Irina for putting this webinar up. It's already the fourth edition. And just a few words from my side. I'm Simon, already almost 10 years in the company of CWB. We're the representatives for selling Fineamin products in Germany. And beside the day-to-day business of serving our clients in regular operations, boiling out newly built power plants or water boilers has become an increasingly interesting part of our job, which leaves us to travel all over the world. And I'm happy to share some of the experiences I gained over the last years with you today. Maybe some first words, what to expect. The introduction from my side you already heard. Then the next step will be to tell you why we are even boiling out water boilers, which procedures can be used or have been used in the recent past, and what are the main advantages of using Fineamin products or filming amine products for these procedures. Then the next step will be to learn about how is it done overall and what are the best practices we experienced over our year-long experience in boiling out boilers. At the end of the presentation, I want to show you how we evaluate the boiling out success and which parameters we are monitoring throughout the boil out. Before in conclusion, I'm happy to hear from you. What are your experiences? What are questions that might have come up during the presentation? So let's go. You can see quite clearly in these pictures next to us, next to the text, that if you build a power plant, there will, of course, be residues during the build-up, during the construction. You'll have all sort of loose tinder, shavings, grease. And before starting up your plant and your downstream steam equipment, of course, you want to get rid of all these debris, all these particles that might interfere with steam purity and might damage your equipment. So the main motivation for boiling out is basically protecting the vapor space and the downstream equipment, superheaters, turbine, and so on. Since the steam boilers and power plants are a relatively old invention, of course, there are several established methods how to clean your steam boiling equipment. You can either use acidic solutions, free sodium phosphate, alkaline solutions, but all of these conventional methods, they come with, I would say, highly disadvantages that you want to avoid. Like, for instance, the security costs in handling highly acidic solutions, the one you would use for cleaning your boiler with acid. And also, as most of you may know, let if you let steel come in contact with acids, the material will be damaged after all. It might get clean, but also it comes with the cost of losing some of your wall thickness, the structure of the metal, the surface. It will get more porous, as shown in the picture above. And if you can avoid that, you should. And therefore, I would not recommend cleaning any steel equipment using acids. With the also well-established method of using sodium phosphate, you have also the problem of the disposal of your sewage water. Disposing phosphate solutions, as you might know, is a big problem in uh, water treatment. You want to avoid that too. Also, adding a salt like sodium phosphate leads to possible deposits of this phosphate on your boiler walls, which you don't want. The phosphate might hide out and show up later in the regular operation of your boiler, which should also be avoided. But the main disadvantage of using a salt like phosphate or caustic soda, for instance, is that you will never reach your vapor steam with this solid cleaning agent, which then results in higher number of blowout cycles you would need to get steam purity. So this disadvantage is also present in using caustic soda. Caustic soda seems to combine the disadvantages of using acid. You have highly alkaline wastewater, quite a lot of that. Also, the risk of stress corrosion cracking later in boiler operation, simply because of the structure of the sodium hydroxide molecule, which also might hide out at the boiler walls and lead to problems later. And since it is a salt, again, you don't reach the vapor space. You have rather long blowout times, which result in higher downtime, and basically you lose money because you cannot run your boiler. About demineralized water as a cleaning agent, I should not leave too many words. It should be clear that if you're not using any cleaning agent, neither alkaline or acidic, the cleaning properties are just very, very bad, and you would need much more time to boil out your boiler to reach steam purity. So you lose money, you lose time, and how to avoid that? Just use Fineamin. You can basically flip all the disadvantages I listed above, uh, flip them from head to toe, and you'll have the advantages of using Fineamin. It's efficient, provides a very fast process, safe to handle, quite simple to use, and overall cost effective. The pictures I'm sharing here with you, they're obviously not from a newly built boiler, but the advantage of Fineamin technology is you can use it either on new equipment, but also if you already have quite old residues on your boiler walls, you might just run it for several time using Fineamin products, and the surfaces will get smoother, the residues will get dispersed, and you can just flush them, and the boiler walls will be cleaner than before. This is a more representative picture. What you want to achieve on your walls is not only clear, smooth surface, but of course also a passivated surface of magnetite. So you want to basically protect your metal walls by building up this magnetite layer. And formation of this layer is favored if you're adding Fineamin because the molecules provided in our solution, they are like a connecting link between the boiler wall and the magnetite that's formatting on this wall. And if you use Fineamin for boil out, you can already have this magnetite layer slowly build up during the boil out procedure, which comes as an advantage for later operation. Again, the advantages summed up in one slide. The wastewater disposal is much easier compared to conventional methods because the water quality you will get boiling out with our product is basically the same water quality you'll have in regular operation. So the plant you're boiling out, they already have a plan of how to get rid of their wastewater in regular operation. And for the boil-out process, it's just the same. It's not higher in alkalinity, not acidic, basically less problematic than in the conventional methods mentioned before. What else? You save a lot of time since you can combine the boil-out already with brickwork drying. Also, you reach steam purity faster because our product is volatile and you have the dispersing qualities of Fineamin also in the vapor space. And what our clients found most advantageous, one of the big advantages of using Fineamin or our services during boil out is that we actually help them monitor the process and give them a certificate of the successful clean out with regards to the measurements we're making during the boil out. So it's not only in the product, it's also in the service. We're helping our clients get the security that actually they are safe to start their boiler. And since the chemicals we're using are effective in cleaning, more effective than the established methods, the client would use much less feed water, less purge cycles, and therefore can start the power plant also faster, which again results in fewer losses of costs. Then I wanted to say a few words on how simple it's to be done. Basically, all you need is a sufficient amount of feed water, of course, the Fineamin solution, which we provide, the dosing equipment, meaning a high pressure pump, that should be as high in the pressure range as is the feed water supply of your client. And of course, for boiling out, you'll need a boil out temperature, which should be above 150 degrees Celsius. And this temperature should be held for at least 24 hours. You can run 2 cycles of boiling out for 24 hours with an exchange of water in between, a purge cycle in between, or even more time efficient would be one single run of 48 hours boiling out. Then for monitoring the success of the boil out procedure, it's just basic lab equipment you will need, like a pH measuring device. Conductivity should be monitored. the level of Fineamin that's present in the boiler. And also quite interesting is the amount of dissolved iron in the boiler. As I'll show you later, you can see in the iron content how successful the boil out or the cleaning of your boiler is running. And the step-by-step introduction in how to boil out your boiler, you basically purge it with dam and water before starting operation, which is like a first step of cleaning the loose parts that are the loose debris. You purge it, you dispose the dam and water of the purge cycle and fill it up, already adding Fineamin to a target concentration of 15 parts per million. And you heat up to reach the boiler temperature of 150 degrees or more. The higher the better, because higher temperature favor the formation of this magnetite layer I was mentioning before. During the 24 or 48 hours of boil out procedure, there will be something happening in the boiler, like the loose the loose iron from the boiler walls. It will basically get dispersed from the walls and flow through the system, and this debris or flowing iron content you will have to blow down to get it out of your system. And with these blowdowns and also the cleaning in general comes a decrease of our Fineamin product. It's basically being used up, so you have to replenish and therefore use your high pressure pump. Once you have your 48 hours and the results you wanted to obtain are reached, you can shut down the power supply, wait for the boiler to cool down, and once it's at 5 to 2 bars, just drain it under this pressure and purge again with demineralized water. And then you're basically done. You have a clean boiler, and what I want to show you here is how to optimize the process. Since it's that easy, of course, there are several ways to make it even more efficient. You can save some time if you combine the boil out, the heating up, and keeping the level of a high water temperature above 150 degrees. You can combine this already with brick wall drying, so you won't have to heat up your boiler twice. As mentioned before, the higher the temperature is, the faster the magnetite layer will form it, and also the more effective the cleaning will get. Since there are like two basic ways of two schedules of handling your boil out operation, either 24 hours twice or one time 48 hours. If you don't want to waste so much water and time, you just keep the boiler running for 48 hours and exchange the water step by step every few hours, doing a periodic blowdown. This is just as efficient as draining it after 24 hours, then filling it up again, heating it up again. The cleaning success will be the same. It's only that you lose less water, less time, and less energy. As a best practice for sampling and monitoring, we found that 4 to 6 hours sampling interval is just sufficient. And how to estimate the success of your operation, you would basically just need to monitor the iron content. If you have a little peak in the beginning, indicating the start of your cleaning process, you will then see a slow decline until at the end of the process, the iron content will just be stable, and you know that there is nothing more to clean because there is no more iron getting dispersed from the walls. what is really important is that after your boiler is fresh and clean and ready to go, you should not let it stay cold or open in contact with oxygen, because then again you lose everything you just established. You have a clean boiler and you let it stand cold and wet. Of course, it will corrode again. Therefore, if there will be a downtime between boiling out and blowout, or between blowout and operation of your boiler, you should preserve the boiler by letting it stay pressurized with a pH above 10, so that no oxygen or carbon dioxide will get into your equipment and no corrosion can occur. Also quite useful for blowout, that is cleaning the vapor space of your boiler, is that you add Fineamin not only to the boil out prior, but also to cleaning of the vapor space. Because during classical boil out operation, there's no contact between steam and the superheaters, or steam and the turbine, whatever is your downstream equipment. And those basically are not cleaned yet. But as soon as you open the valve between water space and steam space, you should also provide Fineamin to get into the vapor space for the downstream equipment to get cleaned. This will result in shorter blowout times or fewer cycles. So again, you can start your boiler more quickly because the vapor space will be clean already. Quite nice picture on how this looks in practice, like how your boiler water changes from the beginning of the boiler operation till the very end. I think, as you can see already by eye, that the iron content is diminishing. These samples, if I see correctly, they're collected over 24 hours. So, as you can see, the process is quite rapid. And I wanted to share with you which results we obtained during our boil out procedures. This is what you see in the graph on the right side. We have the boil out time on the x-axis, and on the y-axis we simply measured how much Fineamin is in the system. So a peak, like in the red curve or in the green one, would mean that we saw in our results that that the Fineamin is used up, and we need to replenish it to keep the pH above 10 and to keep a concentration of Fineamin above 15 ppm. Like I mentioned before, the pH, conductivity, Fineamin, and iron levels are the main parameters we are observing during the boil out operation, because especially interesting is the dissolved iron. We see a little peak, like here in the graph. We have three different boil out scenarios, all of them showing the same decline in iron, and a little peak in the beginning, around about 10 hours after starting. Yeah, I think this is quite good to estimate how the process is going to run. As you can see, at the end of already after 24 hours, the iron content is below 0.2 ppm, so quite good to go. And after 30 hours, there's a stable line. There is no more iron in either one of the boilers to be dispersed or discharged. So the boiler is basically clean, and the client should be happy if we can provide him with fixed numbers that show that actually there is no more iron to be cleaned off the walls. The little peak you see at 11 hours, it's probably due to like us adding some more Fineamin. So what is dispersing the iron from the walls and the surfaces? That is basically the chemical we are adding, the cleaning agent, the Fineamin. But at a point like After 30 hours, when there is no more iron to be dispersed, even adding more cleaning solution to your boiler will not lead to higher iron concentrations because it's basically clean. Oh, and that is already it. Uh, Wrapping up, I wanted to share that we've got 18 years. This is our Berlin office, and you can see down here. I'm sorry that I cannot share with you the names of all the clients we work with, but I'm very happy to give it to you in person. If you're interested, just come around or write us. You can also give us a call. For the little time of 8 years I've been with the company, we already have more than 60 boil-out processes assisted and in our portfolio. So for any specific questions, I'm happy to hear from you now or maybe later, whenever you're ready. Give us a stop by. For now, thanks for your attention, and that's all from my side.
Thank you
Thank
so
you
much.
very much, Simon. And I would like to add something to everybody. So this is Mustafa once again. Basically, one of the most relevant part of all this philosophy of Fineamin treatment, based treatment, is, as you can see, we are not talking in this interesting and nice topic covered by Simon, not something for continuous treatment of boiler operation. So in reality, what we do see through the webinars we covered, so there are multiple applications also in the introduction webinar for the ones who participated into that. So basically, we are using for boiling out, we are using for continuous treatment, and we are using for preservation. So unlike the traditional methods, so Fineamin, film-forming amine-based technologies are giving us this privilege. And this is something definitely superior considering the traditional approach. And here, Simon mentioned about the product name Fineamin 15. I'm sure he will agree. Definitely, we have also some dedicated products during the boiling out process and procedure. But in reality, or in theory, the product that we are using in any site that is based in film-forming amines can be modified in terms of the dosage and can be used in reality for the boiling out process as well. Of course, Fineamin 15 has its own specifications, a bit more dispersion and power, the polymer content, so on and so forth. But in reality, we are talking about different possibilities. So it is quite interesting then, sequence of applications, boiling out with the same product, continuous treatment with the same product, preservation with the same product. So that is the interesting advantages, basically, of the film-forming amine-based treatment. I would like to also just clarify something, Simon, you just mentioned in the later slides about the Fineamin residue, say the product residual, I guess, like 15 ppm. So when you convert this into free film-forming amine excess residual, what would be the content? Or you mentioned this as FFA residual. I just would like to clarify with the people. If you go just down, the later slides, probably it's slide before the last one, you mentioned a graph that will be declining pattern of the iron level. Go ahead, please. No, before
That's
that,
one
please.
before. Yeah.
Before that, yeah. You said 15 ppm. So 15 ppm as Fineamin product or 15 ppm as free film-forming amine excess? Which one?
Fineamin product.
Okay.
This does not regard to the filming amine content, but what we are looking for is what's most easy to measure is the polymer content.
Okay. So you are not measuring necessarily here the free film-forming amine excess, but you are measuring it the polymer content instead. Okay.
And
Okay.
since there is a question in the chat, what type of analysis method we are using to check the residual of Fineamin. Like there are several ways we can either use. Both of them are photometric tests, and it either goes on turbidity of the polymer, or we use the Bengal rosa test for the amine testing.
Yes. So in fact, for fin-forming amine, normally, just to clarify with this question of Gregorio, basically we are having tetrametric method using Hale test kit, and then we have much more precise and high accuracy tests using spectrophotometry. The method is called Rose Bengal, and definitely we are also manufacturer of our own kits, as well as now the famous company Dr. Langeha is also making specific kits for polyamine residual. So polyamine is the same as film-forming amine. That's the same terminology. So all these things are possible. And then, as Simon said, there is also a possibility to measure the turbidity and also the polymer content.
Right. And another question from Gregorio is the iron concentration I was referring to here. This is soluble iron, also measured photometrically using a, I forgot the name of the test, but it's yeah, photometric testing.
Yeah, spectrophotometric. Okay.
Mhm.
Okay.
What
And
else do we have?
Any other question?
there are two in the Q&A section. Can
Okay.
you see them? Okay. Can you use Fineamin for boil out procedure and traditional water treatment chemicals for ongoing treatment? Are there any potential side effects if this is done?
I
It's
said
a
I
good
would
question.
say you lose some money and and nerves using the established water treatment in the regular operation. But if if your question regards mixing both chemicals, no, there are no problems since you're effectively disposing all of your boil out water before filling up again with your regular chemicals. There are
Just
no.
Just one thing, I'm also a bit confused about the question. So it is about the normal treatment, or this compatibility is being asked for the boiling out process? Can it be clarified, please? I mean, someone would like to use the traditional boiling out chemical, like, for example, phosphate or some caustic, along with the Fineamin film-forming amine treatment. Then this question now has been answered by Simon already, so it does not make any sense, but there is no issue about compatibility. But if the people they are asking it for furthermore after the boiling out process, if they would like to have a treatment based on traditional and they would like to switch into the film-forming amine-based treatment of Fineamin products, then we can say that yes, there is possibility, and then there should be a transition procedure, very quick and very, let's say, non-problematic one, and shifting would be definitely easy. I would like to also add a further clarification here. We mentioned specifically and basically an industrial boiler applications, boiling out process. What I mean by this, if we are talking about a boiling out process for a food and beverage industry, of course, we can have a bit different product and different applications too. But it is, again, it's changing based on the request and based on case by case.
There is another question. Could you please tell me more about Fineamin 15 promoting passivation? As I understand, FFA forms a layer on the system, and passivation is mainly a direct reaction between the base metal and DO. So, if the barrier layer is established, how does the reaction proceed? Simon?
Thank you. One thing that came to my mind is using Fineamin, we showed dispose the picture of a barrier layer, since the product is not laying as a layer millimeters or even more thick on the metal. We're not covering the whole surface with a thick layer. The reaction between oxygen and the metal surface is still happening. This is how the magnetite forms. The iron gets oxidized, and our product does not prevent this reaction from happening. However, our product also sticks to the surface, but not as a layer, more as a finely dispersed. I wouldn't say even coating. It's dispersed, so there are
This is
loops or holes in between where the magnetite layer that is forming, it's basically directed by our by the polyamine molecules, so that the magnetite isn't building up and isn't irregularly shaped, but quite firm, sticking to the surface, because it has no possibility to grow into every direction, but only in a very, very thin layer, if that makes sense. It's
basically the film forming amine layer is being, we can say, like absorbed on the magnetite layer itself. This is why we call it pseudo complex, means lying complex or lying layer, because it is there, but it will not impact heat transfer at all. This is one thing. And the other thing is, as you can see, the famous magnetite reaction explanation, that is the Chico reaction. So basically it involves, I mean, for the magnetite to form, you need to have the metal, the water, and then it will form magnetite, and it will release hydrogen. So then when it is being formed with the presence of the water, I would say at a certain pressures and temperatures, obviously, if the people, they isolate that reaction, they will see that the magnetite will formation will stop, because there will be already the film absorbed onto the metal on the magnetite surface, so there will be no any evolution of hydrogen gas in the mechanism. So while if you don't stop it, which means that if there is no film forming amine type of film formation, then this hydrogen gas production will go to an extent, and it may reach excess magnetite formation that may then require cleaning, because then excess magnetite layer will impact heat transfer and will be considered as a basically product to be cleaned off. So that is how the people, they can easily see the formation and stabilizing the magnetite layer on the metal surface. That has been already covered in the previous webinars, by the way, you know, when we are talking about the mechanism of the formation on the metal surface, etc.
Okay, there is a message in the chat. Thank you for your presentation. I dealt with Fineamin long years ago in refinery boilers and cooling system. Another important point of view for Fineamin is when boilers take into shutdown time, this chemical helps very good to protect the surfaces from corrosion during long time shutdown.
That is exactly the case. While we should also say technically, maybe, I mean, more about the general guideline in normal boiler treatment operations. So the common, let's say, acceptance is up to 6 months wet preservation is possible, but beyond 6 months, nobody basically let's say, suggest the wet preservation method. However, if at the end the client is not willing to do anything, is not willing to really discard all the water, purge all the water from the system, so on and so forth, and they would like to keep it wet, of course, this is at their discretion. Technically not preferred and technically not suggested, but this is their choice. So, but a good point that this basically, let's say, feedback reminds me is whenever you have more than one boiler, or you have one boiler but not operating continuously up to 6 days, normally, even if you stop dosing film-forming amine-based chemical of Fineamin, then you should not worry because the film will remain intact even you stop dosing it up to 6 days. So for many other, let's say, traditional treatment way, unfortunately, after 18 hours, when a boiler is fully cooled down, you may see the formation of corrosion by physically just seeing the color. It is yellowish, brownish, reddish, so on and so forth. So in that regard, let's say that the people, they should make the preservation instantly in one way around. If they don't want to see the buildup of the iron or color formation in the boilers, so on and so forth. But the film-forming amine-based technology of Fineamin will give you the possibility up to 6 days not to worry and not to do anything else, and resume operation when it is required back.
Very much so. I'm also grateful for the feedback of Hussein because it adds to the point you mentioned before, that our product is feasible not only for boiling out and not only for regular operation, but you can use the very same product throughout the whole life cycle of your boiler. You clean it before use with Fineamin, you run it with the same chemical during operation, regular operation, and you might also use the same chemicals without changing anything else but the dosage rate for preserving it more than the regular recommended downtime of several weeks or months.
Okay. Any other questions? Just one thing that I would like to say, although we tried to answer the question of Robert. So in case that we get more, let's say, precise reply about the current treatment, for example, in that boiler, and then we can comment furthermore. So you can reach us by email, and then you can say that I have a boiler, for example, with this is specifications, and the current treatment is this, is formed by this treatment chemical. So if I would like to switch to film-forming amine chemicals of Fineamin, what sort of transition or what should I do? Then we can definitely help you more.
Feel free to reach out either to Irina in Geneva or to us in Berlin. I think you'll have all the credentials below the presentation, and whatever question or need emerges, we're happy to hear from you and we're happy to help.
Okay. If there are no more questions, I think we can close this session.
Thank you very much.
Thank you
Thank
so
you.
much, Simon. Thank you so much, everyone, for joining us today. And we hope to see you next time.
Thank you all. Bye.
Bye.
Bye.